Welcome! In this video, we are going to look at problem 24. It is from chapter 12 of University Physics Volume 2 by OpenStax. Okay, so we have a transmission line, so a power line, strung 7 meters above the ground, and it carries a current of 500 amps. We need to find the magnetic field on the ground directly below the wire and then compare that with the magnetic field of Earth. Okay, so let's start with what we know. So in the problem, we know we have a distance, let's call it R, of 7.0 meters. And we have a current of 500 amps, and we can treat this like a long straight wire. All right, and so the magnetic field of a long straight wire is mu 0 times I divided by 2 pi r. Okay, we have everything, so let's calculate it. Mu 0 is 4 pi times 10 to the minus 7 Tesla meters per amp. That's our permeability of free space, and it's the constant that goes with magnetic fields. I is 500 amps. We are dividing by 2 pi times the distance away from the wire, and so that's our 7 meters. Okay, this gives a magnetic field of 1.43 times 10 to the minus 5 Teslas. That's the field directly below the wire. Okay, Earth's magnetic field. It depends where you are, but let's call it V sub E for Earth, is on average 5 times 10 to the minus 5 Teslas. All right, so if we find the ratio, so we do 1.43 times 10 to the minus 5 Teslas divided by 5 times 10 to the minus 5 Teslas. Oh, and we multiply by 100%, we get 28.6%, so about 29%. So that is 29% of Earth's magnetic field. All right, that's going to do it for that problem. I hope you found that helpful and informative. Thank you for watching, and I'll see you in the next one.